Hello everyone and welcome to the IJET webinar, The Future of Water Security. We'll take a look at how the impact of water security and water scarcity will affect your people and operations. My name is Erica Sante and I will be moderating this webinar. We're pleased to have with us today Katherine Harmon, Health Intelligence Expert and Senior Director of Category Intelligence here at IJET, as well as IJET CEO and Risk Management Expert Bruce McIndoe. Good afternoon, Katherine.
Hi, Erica. Thank you.
I'm going to transfer controls to you now so you can drive.
All right. Well, let's step on the gas and we'll get going. All right. Hi, everyone. My name's Katherine Harmon, and as Erica mentioned, I came to IJET a while back as a Health Intelligence Director and am now pursuing other category interests and build-outs with subject matter experts. I became interested in water security several years ago. And being on the Chesapeake Bay in Annapolis, the idea of water supplies is very, very important to us. With me is our CEO, Bruce McIndoe. You want to say hi?
Hi.
Who is a recognized leader in risk management and has also spoken on the topic of water and food security in his Megatrends webinars. So let's go ahead and dive in here. All right, water security challenges ranging from misuse to increased urbanization, climate change, and pollution have threatened many countries. Recently, the Kenya security and geopolitical issues that have occurred over the past several months have stemmed from water control and rights. More recently, riots on September 13th occurred in Bangalore, India over water sharing issues with neighboring Tamil Nadu and their source for water, the Kaveri River. The curfews and restrictions enacted following those riots impacted the technology-heavy region, and this will have a trickle-down effect for the global technology communities. So you can see that water security is more than just opening up the tap on your faucet and getting something to drink, but it has widespread implications for global security and development.
So, one of the things that we look at is long-term trends, and the key trend that's facing us globally is the fact that we're going to put, grow the world population to about 9 billion people from its current about 7.2 billion. So adding 2 billion more people to the planet, basically in the next 40 years at this point, it's going to put tremendous more stress and demand not only on water but food, as agriculture is the biggest consumer of what we call blue water, potable water, and that's tremendous conflict because ag takes away water from what people can drink. So food and water issues are acute now, water being the most pressing. But right on the heels of this is food security and food safety globally. And so we're going to be obviously focusing on water today, and we're going to be doing a follow-up webinar in the near future around food security as kind of two key issues, strategic issues that you should have on your radar as we move forward. Thanks.
Thank you. So what exactly is water security? Water security is not just about protecting global reservoirs and filtration sites. It spans a wide range of issues meant to protect and preserve our sources of drinking water. Humans can last 3 days under optimal conditions without water. After that, we expire. Water security refers to the availability of safe water per person per year, as well as the percentage of a given population that has access to improved water sources. Safe water is considered to be free from frequent or consistent pathogens that are responsible for severe human diseases, or free from chemicals and radiological threats. Water can become insecure through the misuse of freshwater resources, exponential urbanization, as Bruce had mentioned, climate change, pollution, infrastructure failure, or lack of economic support. 1.3% of the total global freshwater supply comes from surface water, including rivers, streams, and reservoirs, and 30% is stored under the Earth's surface in aquifers. The remaining 68, around 70%, is found in the polar ice caps and glaciers, and it's inaccessible. If through overpopulation of a given area or through misuse of water an aquifer runs dry, serious peril will follow in a short period of time. We must learn now how to alter our ways of farming, reliance on livestock, and general conservation in order to preserve a future without additional struggle and geopolitical strife over control.
So one of the key things around water security is this is a tool for national security as well as nation states asserting themselves within the region. So for example, China, all of its major rivers, the source of the water is the Tibetan Plateau, which is why the Chinese have so much interest in the Dalai Lama. It's not about religion or the Dalai. It's about controlling the headwaters of their national security. If someone wants to get control of the Tibetan Plateau and dam and control the water, 3 days later they have a huge national security problem when people start dying. And so the inverse also is happening as China has asserted itself in the Tibetan Plateau and is now systematically damming the Mekong River. Now they assert tremendous control over the water resources for all the downstream nation states, Cambodia and Vietnam notably. And so this is now a tool for diplomacy or war. So water security is a very broad and important issue for any nation who has humans that rely on water for survival.
So what type of things constitute the misuse and overuse? These are major contributors to water security problems that we're having today. The current majority of global irrigation methods for crops creates a cycle of overwatering. This creates runoff when the excess cannot be absorbed. This can then cause soil erosion and subsequent sedimentation into tributaries which block regular flow, eventually leading to the depletion of the surface water in rivers and lakes because of evaporation in the runoff area. Areas in China, as Bruce had mentioned, even the U.S., Sudan, and Vietnam are suffering from the effects of rivers running dry before reaching their ultimate destination, the ocean. This causes not only concerns for humans, but changes in the entire watershed ecosystem. Misuse also refers to the contamination of water once it's abstracted so that it cannot be returned to the ground and considered usable. Industrial process and extraction accounts for a substantial proportion of misuse. Ancillary effects from wastefulness and misuse are immense. Despite many advances and educational efforts that have prompted environmental laws and regulations, as well as voluntary corporate improvements in their effluent and discharge systems, there are many cultural habits globally that need to shift toward a cleaner environment.
So a couple of key facts and messages at this level is that with population growth and the fact that agriculture right now in our current practices, which date back thousands of years, is not sustainable. We cannot generate enough food for the populace based on the way that we're consuming food today. And we're seeing an increase in demand in emerging countries, Indonesia, China, India, where the standard of living and food demand is increasing, not leveling or decreasing. So there's tremendously more pressure to generate more food, which consumes more water, and that's the situation we're in. But the reason that this is so pressing and acute today is back to China. So of the 7 major rivers that China has that feed the arteries, the lifeblood of their country, 6 of them for most of the year or all of the year do not run to their terminus. They are completely consumed before they get to the China Sea. So that is why China is spending billions and billions of dollars in dam projects and water retention projects and water control projects, is to try to avert where they're already dealing with major stress and disaster around water right today. So incredibly important that the countries as well as the globe pay more attention to this issue.
It's very easy to make more people. It's a little harder to make more water. So what are the ramifications of having poor water security? A 2016 UN report on urbanization found that 1/5 of the world's population resides in only 600 cities. As populations in concentrated areas grow, as Bruce was saying, additional land is required for housing and supporting infrastructure. As cities sprawl, particularly when growth outstrips supporting infrastructure, deforestation and encroachment on agricultural land is likely, and water management suffers. In 2015, the World Health Organization reported that only 80% of residents in urban areas had access to adequate sanitation, improved, modern, or separate sewage facilities from where they were living, despite 95% having access to improved water, which met the Millennium Development Goals. Funding for city planners is essential if the current trend of urbanization continues as expected. Resources into preventive health and medical, food security, and housing are going to need to be allocated. All of these basic issues of sustenance go right back to the available water. So water-borne pathogens are quite an issue in a lot of places. Water-borne disease is a significant global killer and coster. Rotavirus is a vaccine-preventable disease. However, only areas with significant deaths due to rotavirus, which causes acute and sustained diarrhea, especially in children, only they actually get immunized. Outside of that, this highly contagious disease causes 100,000 hospitalizations, 275,000 emergency department visits, and more than 400,000 doctor visits in the United States alone, costing a total of $1 billion every year. Cholera is also a deadly disease, mostly affiliated with impoverished countries. Norovirus is another one people have heard of. It's more of a globally seen seasonal disease, usually occurring in the winter, that causes vast numbers of cases every year, many of which go largely undiagnosed, so we don't really know the real numbers. Because other pathogens are filtered with advanced water systems, and these are like the larger bacteria and parasites, developed countries find norovirus more frequently than other diarrheal diseases, which make it appear to be more of a developed country illness. This is a statistical bias and represents the importance of water filtration in reducing other forms of morbidity and mortality that are passed through water and food, because those are more easily screened out.
So, for 15 years we've looked at statistics, especially around people that are traveling around the globe through these various regions and countries. And when we look at the things that actually cause harm to your employees, whether they're local nationals or travelers, the number one issue, and it's not unexpected, is actually slips and falls. So people that just basically get hurt or strained lifting baggage or trip off of a curb or whatever it may be. But the number two issue that it causes harm to your people are food and water-borne illnesses. And this is not only in their own health, but it's also productivity of downtime when they're laid up in the hotel or at home with diarrhea or other stomach issues or whatever it may be. So these underlying things that are happening out there manifest themselves through your employees, through your people, as they get sick. And this is increasing and has been year over year.
So when we talk about areas that are insecure regarding water security, the usual suspects come to mind, and for good reason. As you can see here, there isn't very much water in very arid countries, and they're impoverished and developing for the most part or under conflict, which reduces the percentage of people that have access to improved water. Improved water sources reduce the need for women and children, the typical collectors of water in developing nations, to walk long distances for daily water requirements, and enables them to spend more time on vocational work and education. However, projected population growth, as we have been talking about, is provoking concern among many experts over the ability to sustain the Water Millennium Development Goals, and that's 95% access to improved water sources, and meet new goals across target areas of developing regions, especially by 2030, when growth will be concentrated in developing or impoverished areas.
And so something to think about relative to some of the issues we're dealing with. So when you think about the EU immigration migration problem that we've been living with for over a year now, is not a Syrian problem. In fact, only a percentage of the migrants that are approaching the EU are from Syria. In fact, large numbers are from Afghanistan, and taken in a whole, a very large percentage of those migrants are from Africa. And they're from Africa because of water scarcity, food scarcity, and migrating out of pure necessity. Of course, those lend themselves also to economic necessity, but really it's fundamentally, if I don't have water, I die, and if I can't feed my family, I'm eventually going to perish, then I'm going to move. And so we're seeing that this opportunity through the Syrian conflict opened up the gates and floodgates for these individuals to migrate out of a stressed area, hopefully for a better life. So again, these are all hidden statistics, and these are the underlying reasons why somebody's going to pick up and move.
In a discussion with Kate Bockover, who is one of IJET's subject matter experts for Middle East and North Africa, she related that a lot of people are believing that water issues were one of the contributing factors to the Syrian civil war. So what we know is that between 2006 and 2010, a horrible drought and regime mismanagement of water, lack of implementation of proper water management, including an emphasis on cash crops, caused desertification and drove former farmers into the cities looking for work. The drought affected over 60% of Syria's farmland, including the land around the Daraa, the birthplace of the Syrian revolution. However, there were numerous other reasons for a revolution to begin, and these include a violent regime repression of all dissent, censorship of all media by a leader who was initially brought in for hopes of reform, and accusations of violent abuse of the first protesters, some of whom were children. But water as a contributing factor to this crisis was very important.
Yep. And this is the same kind of thing we see with the whole European migration, is that while it's not the cause, it is a major contributor to why people become disenfranchised, unhappy, looking for help, looking for support, and then that manifests itself in civil unrest and ultimately, in the case of Syria, civil war, or for others, move to another area where I can have a better life.
As we've been talking a lot about urbanization, some of the facts are up here on the slide. And although cities can provide a better life for many with enhanced economic opportunities, a higher standard of living, access to medical care, and diversity of goods and trade, rapid population growth can lead to disaster unless it's properly managed. The demands that will be placed on available water in order to sustain a growing population are vast. We talked a little about the agricultural changes that need to occur, and one of the things we had been discussing right before the webinar was the use of hydroponics and aquaponics. And these methods of vertical farming and ways of growing things that don't require hardly any soil actually consume 90% less water than our traditional farming practices today.
So that's one of the things that I would list under, and we'll talk toward the end here, is kind of reasons for hope. That the trajectory and all of the issues that we're facing right now, if you think about 70% of the water being consumed by agriculture worldwide, blue water, and if we can start modifying from historic ancient farming practices to modern hydro and aeroponic farming, especially vertical farming, we can move farms to these big cities. About 80 to 90% of the 2 billion people are expected to live in cities as we move forward. So that would cut down that whole food cycle from farm to mouth and reduce the 70% component by 90%. So that is one very clear path to how to solve this problem, but that's going to require substantial resources and focus and transition from farming practices to modern vertical hydroponic and aeroponic farming. And that's the challenge, is to have the globe make those transitions in a timely fashion.
So where do we get our water now? What are our water sources that we're so concerned about? Improved water is defined as water for personal or industrial use that is obtained from a municipal water treatment center and piped through the ground to homes or facilities. Rivers and lakes provide a small percentage of water for human use. Typically pumped from the source and distributed to communities, these sources are an important means for maintaining a water supply. In many impoverished areas, water collectors trek miles to these water sources, as we just previously mentioned, often encountering peril and denial of education and vocation just for their daily sustenance. Water obtained from aquifers and wells that are protected is also considered an improved source. However, with overuse, misuse, or even long-term use, these aquifers, dependent upon precipitation to refill them, may become dry or so low that toxic but naturally occurring ores and minerals concentrate in the reserves, making them harmful to health. Reservoirs are naturally occurring or man-made and represent an earth-based catchment system for water, accurately uncovering the best spots geographically to create and maintain reservoirs can protect sources for some time. However, in recent years, water levels in many worldwide reservoirs have dropped to dangerously low levels. Use and construction of desalination facilities has risen in popularity, particularly since Israel helped solve its chronic water shortage by building its Hadera reverse osmosis desalination plant. And yes, that's a mouthful. Island nations with little space for mass reservoirs and wildly varying precipitation have also turned to desalination facilities to meet their needs. While such systems can solve the problem of water scarcity, they are not completely secure or the best solution for all communities. Their cost is one of the biggest drawbacks and makes them out of reach for many developing nations. Finally, precipitation is an important source for many. Basins, barrels, and other means of collection are placed on rooftops or near residences. If the rainfall is low one year, not only do people suffer hardships, but plants can't be watered and livestock dehydrate and die. The World Resource Institute defines water stress as the ratio of withdrawals annually compared to the total availability. Many countries the Institute considers to be under extreme stress are in the Middle East, no surprise there, but they have coastlines available to supply desalinated water for personal and agricultural use. However, many of these countries lack the funding to install and protect these facilities.
So when you look at the population growth on a global map, the highest growing populations are in the areas that are under most water stress. So that's sub-Saharan Africa and Middle East notably, but also in Asia. But when you look at the Middle East, so what the Middle East has oil, and so they have been increasing their level of desalination to create and satisfy water demand. And in fact, the Kingdom of Saudi Arabia, the #1 oil producer in the world, of the oil that they pull out of the ground every day, they use 30% of that oil to power desalination. That's an amazing consumption of energy to desalinate, so essentially boil off the impurities and generate drinkable, potable water. And so that's a huge cost. And so what's happening on a macro scale right now is that all of these countries, all through the Middle East, from Turkey to Egypt and Libya and all the way down to Jordan, are all turning to nuclear power to create the energy that they need, number one, to sustain and generate water, but also their infrastructure. And so we will see a tremendous proliferation of nuclear power. Right now there are 39 nuclear reactors on the books or being built today in the Middle East, driven by the need to survive water.
And that's a hefty cycle there, because nuclear power also uses water to cool their systems. And so some of that water that is going to be generated by nuclear reactors is just going to have to go right back into the nuclear system and be unusable in the future. All right, so what are the threats to some of these sources? You know, as we spoke before, damming can help by controlling water flow and rate, as well as by providing power. However, in some areas, the government control over the rate and flow derived from dams may cause civil unrest and geopolitical stress. Aquifers of differing depths and amounts are largely dependent on precipitation for replenishment and can be tapped into and piped to the surface, but the quality and purity of this water may vary greatly. Ores found underground can leak into aquifers and create health issues, like we're seeing in some areas with arsenic and uranium. Whether there is a water shortage in arid areas that have suffered extended periods of drought, or an overabundance of water from heavy storms, typhoons, and hurricanes, both situations are equally threatening to the available water supply. Additionally, pollutants, agricultural misuse, and disease are lesser known threats to the water supplies, but are nevertheless vital for effective distribution of potable water.
So on the whole damming issue, so I talked a little bit about China. So to put some facts, so right now China has built 7 dams on the upper Mekong River. That's today, ostensibly to generate hydroelectric power, but it also controls river flow, obviously. And they have plans, and they are funding 20, or have plans to put 21 more dams along the river. So that's an amazing, one, just investment in infrastructure, but 2, unprecedented control of the water spigot in that region. And so as there is challenges, for example, Vietnam to China around the South China Sea and control of that, on their left flank, the Chinese could basically say, if you don't shut up, we're going to turn off the spigot. Is an incredible lever for them to have further and assert further control in that region. So trying to paint a picture of understanding that many of these mega issues that are out there today that also impact the U.S. and our role in that region can be directly either linked to or influenced by water.
Okay. Yes, so in speaking of dams, controlling through diversion of water is an important threat to water equity, as Bruce was saying. Resource management and environmental manipulation can also be harmed by damming or water diversion through canals and irrigation streams. Although dams, hydroelectric plants, and farming channels may be necessary for one area's subsistence, the follow-on effects of downstream activity and change must be taken into account lest tensions arise. Sorry about that. Overuse and contaminants are another threat to our water. Overuse and lack of longevity of what we consider the below-earth supply of water is a growing issue. Wells and aquifers are becoming depleted with increasing demand. Globally, more and more contamination from archaic systems and effluents is being found in the water that's even deep under the earth, even in developed countries. In fact, developed countries in heavily industrialized areas are seeing their water sources made unusable. Recent lead levels in Flint, Michigan, and chemical spill in West Virginia left water unusable for extended periods of time. In 2010, a breach in the reservoir holding toxic waste in Hungary caused a massive spill that affected the Danube River and many other European Union countries. Stories like this can be found globally, whether it is in abandoned mine chemicals contaminating water reserves, agricultural contamination from flooding and fertilizer runoff, or depletion of wells concentrating uranium or an arsenic. These situations are all too common in a world that relies on the ability to cleanse its water supply.
Mm-hmm. On to the fun topic.
Yeah. So other things that can happen are things like terrorism or just worker strikes and unsupported infrastructure. Aging systems that may have used toxic metals or insulation back when we didn't know any better can have a detrimental effect on what we might think is an improved delivery system. Improved systems that may have been installed but undergo no routine maintenance or care are also a threat. Leaks in pipes from large facilities all through to their end user have been blamed for rapid depletion of water sources and sinkholes. Worker strikes at desalination facilities or municipal improvement facilities can render a large threat, especially to nations that do not readily stockpile water to drink in times of extended unavailability. Finally, terrorism is a real concern among many municipalities that rely on only one source for water, such as desalination. Should a desalination plant be rendered inoperable, thousands may suffer or die from the lack of water. We hear a lot about climate change, and despite some of the naysayers still holding on to the belief that climate change is not real or within the normal boundaries of the Earth's evolution and devolution, the effects cannot be denied. But for centuries, atmospheric carbon dioxide levels were or at below 300 parts per million based on NASA ice core samples. After 1950, with heavy use of cars and industrialization and large population booms, levels have steadily risen until today's new high of 400 parts per million seen this year. The human activities that contribute to these levels not only stem from industrialization and carbon emissions from vehicles and factories, but on livestock practices, where emissions from cows are now recognized as a leading contributor to climate change. As we evolve economically, diets have markedly changed. Large areas and cultures whose food source was mainly plant-based now have the financial resources to buy meats. Consumer demand for beef, pork, and chicken have led to crowded ranches and farms. Water that's needed to maintain meat-based diets is very high, and the harmful byproducts of meat from ranching practices is contributing to climate change. A need for moderation and cultural change is one of the solutions that we can do.
So two things here that at the kind of mega picture is, one, a tremendous amount of potable water is trapped in the polar ice caps, which are melting. And as everyone has heard, whether they believe it or not, that this over time is going to contribute to sea level rise. And so while we're having this conversation about potable water and water availability, it's the other side of this picture is the fact that in 75 to 100 years, with sea level rise, we actually will live in a world where there'll be too much water as actual water, even though it may not largely not be drinkable because it's seawater. But we will see cities, islands that will disappear from the face of the earth, i.e. underwater. And so we're going to also deal with kind of a double whammy, and that is availability of potable water, drinkable water, with tremendous increase in water on the globe. And what that's going to end up doing is just further exacerbating migration of human populations. So cities that are along sea areas that are going to be inundated and underwater are going to force the inhabitants to migrate and move inward. And so that's just another stressor on what we're dealing with relative to water. So it can be good and bad.
So a good graphical picture of effects of climate change over the past 10 years comes from the National Oceanic and Atmospheric Administration's Centers for Environmental Information. In July 2006, an index of U.S. drought showed significant and large areas of extreme water poverty in the United States, as you have. Significant areas of reduced precipitation were evident in the north central and southwest areas of the U.S. Advance 10 years, and you can see a big difference in the areas of where extreme drought is. It's shifted, and although they appear to be reduced in a total area, there's a high increase in moderate drought encompassing much of the Southwest.
So just one of the things that when you look at this map, which is interesting, and if you play it forward for another 30 years, the agri-land for North America will shift north. And actually, where the breadbasket of North America has been our Midwest, in the next 30 to 50 years, that's going to migrate where Canada will create about 30 to 40% of our agri-land in North America. So as anybody has some spare money, buying a couple thousand acres just over the Canadian border would be a good investment over the next 50 years. So there's your wealth tip of the day.
Stock tip of the day. All right. So in continuing on that theme of money, government control and pricing out of water is very country dependent. So some governments have very tight control and restrictions over water use and consumption and how they use it as a commodity, and some are just now learning. National, regional, municipal surcharges on water delivery may contribute to the inequity in service and delivery and cost tensions or other health concerns, but it may also be one of the saving graces in the solutions. Taxing water and controlling usage has been a solution in California, where they have a structure that you can use up to so many gallons and it's priced at one rate, and then anything over that average consumption period for their residents is about 3 times higher per gallon. That adds up pretty quickly and is a great incentive to fixing leaky pipes, or toilets that won't stop running, or teenagers that take extra long showers, because your water bill will become extremely high.
Yeah. And that's, again, a model that says we're not going to overtax normal human consumption for survivability and livability, but if you overconsume, then you got to pay. And like you said, it really gets people's attention when they get a $200 water bill. And it's like, what?
Yeah. It got mine. All right. So we've been talking about all of these woes. Is there any hope for the future? And as we discussed, there actually is. If we look at 2 successful countries who have managed their various water crises, we'll see that a lot of it is dependent on having a mixed bag of solutions. First, we'll look at Singapore and its example of well-thought-out management. Not relying on one source, Singapore derives its fresh water from rainwater catchments, imported water from neighboring water-rich Malaysia, desalination facilities, and water recycling. Failure of any one of these sources could require alteration in consumption patterns. However, an overall failure to meet basic water needs is very unlikely. In seeing today, Malaysia, in fact, is undergoing a lot of upgrades to its water systems and availability, and so cannot export to Singapore over the next few weeks while it's undergoing its maintenance and improvements. But Singapore is unlikely to suffer because it has these other methods of fallback. All right. Another good example is Israel. Israel has been considered one of the most innovative and successful water resource countries. Facing a water crisis in the 1950s, a gradual system of water conservation, effective administration of the Jordan River system, and the discovery of natural aquifers have led to successful water management programs. Many factors should be carefully analyzed when considering desalination facilities as a solution to water scarcity or stress. But this is one of the things that Israel did to help solve its problems, and especially revamp the way it was doing agriculture. Right. Mm-hmm. So what are some of the solutions?
I call the reasons for hope.
The reasons for hope, yes. In the distant and recent past, solutions to water crises were event-driven. Years of extensive drought, or conversely floods, led many areas to reconsider water management practices and solutions, but few have sustained over time. Desalination, the savior of many areas, is not an optimal solution to water scarcity or stress for some areas. As we discussed, it's just too expensive to build a $3 billion, U.S. cost desalination facility for some of these smaller or poorer countries.
And feed it energy every day.
Many factors should be carefully analyzed when considering desal facilities as solutions to water scarcity or stress. Return on investment may need to be long-term and not a short-term solution. However, the outlook for water supply and demand necessitates being creative, and comprehensive cooperation in procurement and management of fresh water through funding efforts, government incentives, a cultural shift toward considering water a commodity, replenishing reserves with improved management of stormwater, and new technologies that require less water to produce goods and services or to treat wastewater are all some of the viable solutions that we can draw from. Back in 2012, the intelligence community estimated that by the year 2030, demand for global water will exceed the sustainable supply by 40%. Regions may be impacted in different ways through climate change, and poor water management will affect the entire global population. Deforestation, construction and clearing, poor erosion control measures, contamination by effluents and saltwater intrusion will also affect our supply. Taking measures now to remediate problems currently existing and most assuredly becoming a major threat in the future to conserve water is absolutely essential.
Yep, and as we look at the World Bank work that is happening there, the UN and other institutions, the number one focus for long-term sustainment is major changes in farming and livestock practices, i.e., food and protein, vegetable and protein foods. And so there's a clear path around the farming arena relative to changing from land and irrigation and those very inefficient historical farming practices to modern hydroponic and then aeroponic farming. So that requires a upfront investment in infrastructure in order to make that shift, and countries are starting to look at that and starting to do major implementations of those types of systems to kind of prove them out and start legging into this to get that solved. The other is livestock. It's protein. And the technology that's there, which takes me back to my youth with the Jetsons, when you walk up to the oven and you plug in bacon, and then you hit a button and then you open the door and bacon comes out, is actually pretty close to reality. The ability for us to now manufacture proteins it exists today. In fact, we actually create organs now through essentially laboratory manufacturing processes. And so it's not a far off distance that we would be able to create proteins that then would be used for consumption by humans versus growing them on a live animal. And so that is the direction that science is going, and it's proven out. Now it's a matter of getting to scale. But the other technology is what they call granularification of protein, and that's where the magic, being able to print a hamburger, is also within the reality of the world. When I can then load up in a hopper into a printer, essentially protein granular material, and then bond it to a substrate that would hold it together and then add flavor, I can actually 3D print a very beautiful beef patty and then eat it, and I'm sure it won't be as delicious as what we have today, but it'll probably be pretty darn good. So that's where we're heading in the future, to remove one major contributor to two big problems. One's water consumption and the other is greenhouse gas emission, and that's by substantially reducing the level of livestock that we raise and slaughter and eat on a daily basis. So just those are some future things that are happening today that we'll see, probably in the tail end of my lifetime, but definitely our children's.
Yeah, and part of the reason that this is so important is it takes about 6 liters of water a day to raise a cow from birth to market. Roughly half that for pigs and another half that for chickens. But when you add it all up and how many of these animals are being consumed and how many liters of water every single day are going to those ranches and these farms to support this market, that's an enormous expense. So what are some of our key takeaways? We've heard all about water stress and water security, and a lot of terms have been thrown around, and a lot of future outlook. But the thing to remember is that the global water crisis is actually happening right now. Urbanization and methods of farming and industry is going to exacerbate this crisis, and as population grows, most assuredly, things are going to get worse. As we said, we can always make more people, but it's really hard to make more water. We need to change our ways of managing and collecting water, but more than that, it's a whole culture shift that is going to be required. When you're traveling around, you should be aware of any regulations on water use. Some places will only allow you to shower for a couple of minutes, 2 or 3 minutes in areas where water is scarce, and not take extended showers if that's what you're used to. When you're consuming water, use bottled water from reputable sources to prevent gastric irritation. There may be contaminants in some places and in countries where water is very pristine and they're very proud, and they should be, of their freshwater sources. Sometimes different methods of treating that water can cause some stomach irritation.
And also when you're traveling to certain countries, and over time this probably should just become a practice, but there are a lot of camping water bottles now where you can fill that and actually have a pretty effective screen against not only contaminants but also viruses that may be bacteria and viruses that are in the water by just running it through a filter and being able to carry that just like you would carry a water bottle. And they're not particularly expensive, and if you're traveling around Africa and other areas, I would say that should just be something that should be glued to your side 24/7. And even if you get a bottle of water to pour it through that and then drink it, you're going to be a lot better off.
Yeah, a lot of these products, as Bruce was mentioning, have filters that are good for about 1,000 liters at a time before they need to be replaced. Mm-hmm. And then it's just the filter that needs to be replaced. You don't have to replace the entire bottle. So it's a very ecologically sound way of doing it, rather than contributing to our landfill problem, which will most likely be the subject of another webinar down the road.
So eat cooked food, peel fruits that you're going to eat, and filter water, and you can substantially reduce risk. So.
And knowing that water is a problem now and is only going to be a worse problem in the future if we don't take steps to remediate that right away, corporations that are looking to expand into a lot of these emerging markets should consider the possibility of water problems, either in their delivery or cost. As people realize, and as governments realize, that water is a commodity and that they can make places sell for it, operating costs will certainly go up. And we're all global citizens. We're all responsible for helping to shape our future. So we need to balance our needs with our resources for a resilient and sustainable future.
Super. So I don't know if there's any questions. I guess people can pop into the little chat area, and I don't know if there's anything.
All right. Thank you, Bruce and Catherine. I'm going to probably stick to my veggie burgers. Those are some great suggestions. We have some time for questions and answers, and we had a couple questions come in, so I'm going to read those for you guys now. What countries are the biggest players in the water wars, and which countries are contributing most to the future safety of water for the world's population?
For the world's population.
Well, so I guess that is, so right now China is the undisputed financial investor in water management / control globally. There's no question there. And depending on how you look at it, it can be stewardship of the water resource, or it can also be a method of control of its neighbors. So, so depending on how you read that question, they are probably the ones right now, because of their inherent wealth and desire to pour that wealth into this important infrastructure right now, are the #1 leaders. The Middle East as a collective are #2 in the sense of infrastructure spend in focusing on desalination as their long-term survival path for their populace. And as I talked about, not only driving this through natural gas and oil, but also moving to nuclear power to create the energy that's needed to create water. So those are really the major players. The United States, unfortunately, is kind of sitting on the sideline. There's a lot of, conversation and wringing of hands and watching the Mead, what's the reservoir behind the Hoover Dam?
Yeah,
Lake Mead. Going down and measuring the aquifer reduction year over year, and everybody saying, yep, this is going to be a problem. But right now, we've not invested in any strategic solution to that. I guess as it becomes more acute over the next 5 to 10 years, then we'll make some heroic effort and figure it out. But right now, I'd say those are the major players that, as far as investment, and then of course the U.S. that can shift capital resources, but right now has not chosen to do so.
Right, and like we were saying before, a lot of things are event-driven. So the Middle East, kind of has this looming crisis all the time over their heads, and they had to solve some of these problems. And that was why Israel was one of the standout countries in what they did, and for long-term solutions as well as for short-term needs. China seems to be being proactive
for its own protection, for its own security, but also with an eye toward regional influence.
Yeah, absolutely. And then the U.S. is just going to have to catch up.
Yep. Okay. Erica?
On that note, desalination doesn't seem to be a very complex process. Why is it so costly?
It's physics. So basically you have to elevate the temperature of the water to where it becomes a vapor. And then the vapor rises, leaving all of the impurities that you don't want behind. And then you cool it down back into its liquid state, and then it becomes potable water. So the energy required to elevate water, to 212 degrees is expensive, very expensive. Just like when you put a tea kettle on your stove, you're consuming a lot of energy. Now there are other technologies, reverse osmosis and other things that are being applied, but in massive quantity of desalinated water production right now, boiling and vaporizing water is the most efficient in quantity, even though it's very costly.
And as Bruce had mentioned previously during the webinar, it takes a lot of energy to do this, and so it also depends on countries' availability of energy sources, whether they're using fossil fuels or nuclear fuel or hydroelectric, which is just kind of backwards in those terms. It's going to require both water, oddly enough, and energy to produce this water for people.
But countries that, Saudi's lucky, they pull it out of the ground and use it. So for them, it's a lost opportunity. They didn't get to sell that oil on the market. But for many countries, they have to buy the energy, and as we know, that's crippling for many countries. So.
Okay, great. Another question's come in. What can private companies do in order to preemptively address water access issues that could affect operations in developing countries?
So most of our clients that we work with, especially in developing and water-stressed countries, basically take on water production within their own bounds. So if they have a compound or other structures or manufacturing, they really focus on, how do we create sustainability and support with our own water sourcing, usually through wells or other, water catchment strategies. And but most of the companies that we work with are very, very focused on how do they manage water supply through their own efforts. This includes also creating and purifying water for drinking, but also recycling wastewater back into the system. And in the case of many of our companies that are doing manufacturing abroad in water-stressed environments, have nearly a 100% recycling. Every gallon of water that they put into their manufacturing cycle through the waste cycle and then recycle it back to the front of the system. And there's very, very little, 3 to 4% loss of that water in that cycle. So it's that sustainability and engineering that is what makes it work. And likewise, if you don't have this, then you're putting your business continuity and resiliency at substantial risk.
And bringing these best practices to some of these developing nations and letting them have a glance at the technology and investing in these countries will also help them in the future so that they can be better conservators of water.
Thanks, Catherine and Bruce. One last question. Where can I, this is on farming practices, sustainable farming practices. Where can I find the status of research on farming methods to reduce water use and also research on seeds that require less water?
Well, a couple things. We are going to be addressing a webinar in the near future on food and food production, food safety and security, and that's a big part of that conversation is how do we produce the food. So we will be having that down the road. I believe you have a white paper that you're making available around the water security, and what we'll do is we'll pull some research and links on agri-production and the relevant water savings of hydroponic and aeroponic solutions to that, and we'll include that. So if people are going to go and pull down the white paper, we'll also include a little bit on that as kind of a teaser into the next webinar.
All right, sounds great. So we are about out of questions and out of time. This webinar is part of our free monthly webinar series, and I just want to point out that we have our next two webinars coming up are Emergency Preparedness, the what, the how, and the why it should matter on October 12th at 2 p.m. in partnership with As Is International, and this one will be led by IJET's organizational resilience expert, Michael Payne. And then followed by How Do You Know Your Data Loss Prevention System is Working on October 27th, featuring cybersecurity experts from our partner organizations, Lemonfish, Digital Guardian, Lafarge, and Kilpatrick Townsend Stockton. You can register for our live webinars and explore on-demand webinar topics on our website at www.ijet.com/webinars. Thank you everyone for your time today and for tuning in. Be sure to take the brief survey that will pop up as you hop off this webinar. If you have additional questions about the material we've covered today, please let us know via the survey. Thank you, Bruce and Catherine, for your time as well, and everyone enjoy the rest of your day.
Great. Thank you very much, Erica. And get your flu shot.